Okay, so it's 6. I will wait 2-3 minutes more, then I will start the session. We'll be solving some. I will give a recap of this week, what was taught in the class and in the lectures, and then we will solve some problems, MCQs. Yeah, okay, let's start. So, hello everyone, my name is Srijoy Mukherjee and I'll be taking this doubt clearing session for NPTEL course on operating system and fundamentals. So, I'm a research scholar at the Department of Computer Science and Engineering, IIT Kharagpur. Uh, this session is for doubt clearing as well as for some problem solving. So, basically, I will be solving assignments from previous year. That is quite in line with what you are solving for your assignments this year. That will be helpful for your final exams also. Other than that, you can ask any doubt while I am covering the recap, and also during any questions, just use your mic to answer any doubt you have. So let's start. Uh, let's start with first the recap. I will be sharing my other screen. Okay. Okay, so the concepts that were covered this week was a basic introduction to operating system. So also computer system organization, those kind of things, memory, process, storage, etc. So let's dive into it one by one. So uh, I assume some of you are very new to the subject of OS. Some have little background to it. Some have little background to, let's say, data structures or let's say computer organization or architecture. Uh, so that is a primary fundamental that you require. Little bit of knowledge you require, like how computer programming works, to understand how operating system behaves and all. So what is basically an operating system? If somebody asks, yeah, if you have any question, you ask directly. You don't have to raise your hand, Salman.
Service provide an interface between user and
No, no, no.
hard.
Salman is raising hand. Do you have any question? Yeah, yeah. So okay. So what is operating system? Operating system is basically I will not say that it is a interface between user and hardware. Okay, so let's get it this way. So what happens if there is no operating system? What happens? Suppose you have a typewriter. What does a typewriter do? In a typewriter, you are just writing some lines and it is being typed as it is. So does a typewriter has a OS? No, a typewriter doesn't have a OS. So what is basically a OS? OS is basically a program that helps you to associate with the hardware. So let's suppose you are using a keyboard, right? You are using a keyboard, but you need to reflect what you are like when you are using a keyboard to how it works, right? You don't understand, just you are writing some things and you don't understand how it is working behind the scene, how it is being typed. So it needs to be able to communicate. You need to be able to communicate with what is happening with the keyboard. So you are writing something and you are not able to understand what you are writing. So in that case, OS helps, right? In OS that helps. That OS has very different kinds of things. Like even your mobile phone has an OS these days. Even let's say your small architectures, like these days you have those smart TVs and all those things also have an OS. So it provides a way to interact for your user directly to the hardware any hardware at this point. How things are happening around in the world of computer science. So operating system helps in such problem solving. So nowadays OS is not just limited to your computers. OS is in every interface that humans are interacting with the introduction of IoT, Internet of Things. Everything's are connected. So OS, the importance of OS has increased rapidly for this. So other than that, let's say now let's come to what is your computer consist of. So in plain terms, your computer has a CPU, a list of hardwares, let's say peripherals, what people say, a keyboard, a mouse, or a printer, or, or there is the memory device, the RAM or something. Shall we provided with any question banks before examination? Your assignments are your question banks, nothing more. Okay, your assignments are your question banks. Some things, some questions I will discuss in this. These are also kind of question banks. You can consider that, nothing more. Exam you don't worry much about. Those paper is quite common to how the assignments are. Okay. From my experience, I have seen that those questions are quite common to how what are discussed in these assignments and all. So computer system has an hardware. The hardware is basically your CPU, memory, I/O devices. I/O devices are previously you used to have DVD, CDs. Nowadays you also have your pen drives, your internet adapters. Those are kind of I/O devices. Then you have operating system. You need the operating system to control those things. Not only to interact with the CPU, but also with these peripherals. Now, what is application program? So, all of you have interacted with your with this thing called DOS. Have you heard about DOS, right? So, what is a DOS? Disk operating system. So when you are using DOS, have you used the commands like list and all, right? So what is a list? List is an application. So when you are typing a list in your command prompt, so you are basically telling to you are basically telling the OS that like the computer, just give me the list of the files that is present in this folder, right? So that list command uh, is a program, application program. Now it interacts with the OS. And first of all, where are these files stored? These files are stored in your hard drive, right? So I can't explain in Hindi, right? It is uh, Hindi is not my first language. I'm not much comfortable in. So, and there are other students also who may not understand Hindi. So, so if you have any doubt, you can ask me in Hindi. Then I will let you know. Okay. So, what is your application program? So that I am saying that basically you have used this command prompt. In the command prompt you go and you type that list of files that let's say in Unix it is ls, a simple command of ls that gives you the list of files. Now where are these files stored? These files are stored in your in your main memory or your, let's say, hard drive. Your hard drive stores it, so it is a hardware. So when you are telling the CPU to give you a list of hardware, so who does this execute? Who does this query fetch? So this query goes directly to the your OS. You are basically asking the OS. You're basically asking the OS that give me the list of files. The OS in turn asks the CPU, communicates with the hardware to find out how many files are stored in your hard drive. So that gives you the list of files. So that is how OS operates. So in other words, OS is basically a set of programs which are stored already in your computer, and with which you can interact to write other, perform other works. Like the application program is basically your list of files, so querying the list of files, the ls command which is there in Unix, and the output is basically fetched from the hardware by your OS. So OS is basically a set of programs that are already stored in your computer. Now delve into more details. This is how a, structure of your uh, operating like how operating system uh, operates. So first you have the computer hardware, and a layer on top of it is your operating system, and then you have your application programs. So just I was saying that assembler or kind of text editor, like those kind of things operates directly with the user, and they fetch those kind of queries directly to the operating system, and operating system bridges the gap with the computer hardware. That's how it works. Next, so what does operating system basically do? So operating system basically controls the hardware, from what we understand, that when we are fetching the list of files, it is asking the main memory that how many files are stored in this drive. So basically it controls the hardware and coordinates it within the user. Now the other thing is user view. So what is an user view? So you see in your in your laptop or desktop, whenever you create a new install a OS, it gives you an option like create a user. So what happens when you create a user? That user interacts with that operating system. Now there is, in that PC only you can create more than one user, right? But both users will have the different control over the OS. So that is a multi-user computer. It is already present in your laptops and desktops which you are operating in these multi-user OS, but it is uh, people use it still. Now, other types of computers that are we are talking about was these embedded computers. So embedded computers is like nowadays, if you have seen the latest cars and all, those also have an OS. They are also supported by Android or something. So those are called embedded computers. They are not available to for much bigger set of works to be done. Basically, they just may be used for using your GPS or for playing songs or videos. But those are also embedded computers. Even those Amazon Fire Sticks that are available, those are also kind of embedded computers. Other than that, other than that, you have the other job of operating system is resource allocation. So what is resource allocation? So if you go to your laptop, there is this thing called Control Alt Del, and you can go there and see all the list of programs that is currently being run. So that is called processes. Now the OS only allocates what amount of resources each of them are allocated. For example, you are using Word, and suppose your memory in your laptop has 8 GB RAM. Now it is the job of the OS to allocate how much RAM will your Word be allocated, because it is not that only Word you are using. You may be using, along with Word, you are also playing music while working on MS Word, right? So these are two different operations: writing text and playing a music. So what does resource allocation means? So this resource allocation means you will be OS will be allocating particular amount of RAM, memory to this Word application and also your music playing applications. So that is called resource allocation. Also, there is control program. Control program means to prevent errors or improper use of computers. Uh, so, like for example, that you can consider password protection a form of control program. That is also a very big application for OS, because you see, while you are writing the password, it is not stored in direct like plain text is not stored in your computer. It basically is encrypted and stored. So that is also a kind of control program that OS does. Next, so basically these are all the functions that OS does to solve various kind of computation problem. So now another term with which OS is generally attributed is the term called kernel. This kernel term you will come to hear about a lot as the course progresses. Now don't confuse it, what is like you don't start asking difference what is a OS and what is a kernel. So basically OS is actually kernel. Then these are name that are just given. And why it is called kernel? Because once you power on your laptop or desktop, basically your PC, it this OS runs until and unless you are closing your system, shutting down on system. So it is always on. So that is why it is called kernel. So there are many programs associated which are always running behind the back while to keep this your system running. So that is what OS does. To dive into much more details, you have your Android phones that those have a kernel. Along with that, they have some middleware. So you will be asking, what is a middleware? Middleware sits between your core kernel and other stuff. So what does middleware do? Middleware supports your databases, multimedia, graphics, etc. So we'll come to middleware after in few slides. We will talk about it. So so this is the system of how the computer system currently looks like. So you have an hardware, on the top of it you have your operating systems, then you have your database systems, then on the top of them the application runs, and then there is the users which runs the applications. Okay, so next now come to another important topic, that is computer organization. uh, how many of you have studied computer organization before this subject?
The computer organization is done. Hello.
Yeah.
Sir, computer organization as an architecture like x86, 64 and ARM based.
Yeah, I mean, I don't want to dive into the details of what is the difference between architecture and organization, but let's say it this way. Uh, Organization is basically, can you please shut your mic, Kalpesh? Yeah, thanks. Organization and architecture has a subtle difference. So, organization is basically uh, what computer organization deals with is with that your computer, you have a CPU. Now your CPU may have a floating point addition device, may have a, particular setup for your, let's say, matrix multiplication. So these are the things that defines how a computer is organized, how a CPU is organized. Whereas on the other hand, computer architecture goes way further. It defines what level of these floating point numbers that are present, that can be done using multiplication can be done in it. Okay, so one specifies what kind of floating points it can support. So computer architecture defines what kind of floating point it supports. Let's say it says that I can support 3264 bit numbers multiplication. What computer organization does is how are you going to multiply it. That part is taken care of by computer organization. So as a part of computer organization, there you have, if you look at the hardware setup, you have your CPU, you have your input output devices. These are some of the main components, and then you have your RAM and secondary main memory, you say, those kind of things, and let's say secondary memory like hard disk. So these are the things that typically are part of your computers. Now the peripherals, or let's say the input output devices, each of them have something called device controller, and also they also have something called device driver. As the name suggests, these are two different things. I know this is a little bit confusing, what is a controller and what is a driver, but let's in simple terms, let's say a controller is associated with the hardware and a driver is associated with the OS. So let's say you have a keyboard. Your keyboard will have a controller. That controller is present in the hardware. What does this controller has? This controller has a thing called small CPU. Let's say let's go in very uh, mild terms. It has something called a small CPU. It is a small CPU. What does it do? It checks that the number of requests that have arrived, how many number of requests it has to serve. Okay, so it gets keeps a count of that, as well as it has some own of your buffers, like buffer in the sense memory, local storage memory, before it sends the message back to the CPU. So let me explain it by a little bit of drawing. How does what is the thing I'm trying to say? Okay, so here you have your, let's say, your keyboard, and here you have your CPU. So your CPU has some memory. Now this, here you have your controller. Now here you have your controller, and also you have some buffers. What are buffers? Buffers are basically memory. Buffers are basically some memory. So how does this CPU operates with your keyboard? It operates via some, let's say, some channel. So it sends a request, or this sends a request. Let's say this sends a request. Uh, this sends a request that, let's say, user have typed K, and the CPU says, okay, I have received it. This is the, let's say, acknowledgement that CPU sends. Now let's say the CPU has not acknowledged right at the time this symbol K has arrived here, right? There always can be some delay, right? So what will happen in that? And you are typing the word key at a very high speed. So what will happen in that? The terms E and Y will be stored in this buffer, and after an acknowledgement comes from CPU, this Y will get transferred here, and after that acknowledgement comes, this E will. So this is the reason why buffers are used. So controller manages these things, like whether acknowledgement has been received or not, whether buffer is empty or not. These are the things which your this controller takes care of. Now the other thing is the OS. The OS communicates with your CPU, and this happens on the background. Now for the OS to communicate via the CPU to the keyboard, it requires something, right? It cannot understand directly what kind of keyboard is this. Okay, your keyboard can be of not different type, but of different companies, like some Asus produces some kind of keyboard, Dell has some kind of keyboard. So you need to understand what kind of keyboard it is interacting with. So what does it do? So to do that, this company manufacturer, let's say it is Dell. Dell also has something called, let's say, this keyboard driver. The job of user is to install this driver in the OS. Once it is installed, now it is able to directly communicate via the CPU with this keyboard. So this is what is your driver. Clear? So this is the difference between your driver and controller.
Sir, sir, one doubt is there that while we normally we had just that USB connected keyboards which we directly connect to keyboard without installing any device drivers.
No, device
Right?
driver always installs. Okay, yeah, if you just install like use a mouse or something, you see that in the background, even if you insert a USB keyboard, you will see in the background it checks that whether device driver is installed or not. Okay, if you are using a Dell desktop and you are connecting a Dell keyboard, maybe that it is already installed. Okay, but always it checks when first time you are inserting keyboard to your USB or something. It always checks that whether the driver is present or not.
So next time or repeated times it does not check.
No, no, because at that time it checks that driver is already present, so it doesn't have to install or not. But it checks whether the driver is present or not every time when you insert it. It also maintains, like obviously your software OS is maintaining that record. Okay, that is the beauty of OS, that it has to maintain a record whether the periphery has already been used previously or not. So this is how controller and driver works. Both are in two different domain. One is in OS domain, another is in hardware domain. But that is how OS and like computer organization and architecture works. Okay, so let's now get back. If you have any doubt, you can ask other than this.
What is the difference between device driver
Mm-hmm.
what is the difference between device driver
And
and device controller?
that is I said to right. This is the in this part, in the hardware part, you have your controller, and in this part you have your device driver. So shall I
Okay,
repeat?
sir.
So shall I repeat again?
Yes, sir.
Okay, so okay, so let's clear this up again and let's. So let's say you have a Dell keyboard, and here lies the controller. Can you see the screen?
Yes, the connection was dropped
Yes,
in.
sir.
Now it is back. Can you see the screen? Can please anyone confirm it?
Yes.
It is fine now, right?
Yes, sir.
Yes, sir.
Okay. So you have your controller here. Then let's say you have your CPU and you have your OS. So you are writing something, and let's say these are your buffers. CPU also have something called registers, your cache, your main memory. Okay. So what does the so in basic terms I will say that this controller is kind of a mini CPU for your device. Right. So how does a keyboard will work? So suppose you are writing key. Okay, this it doesn't happen like this, but for the sake of example, I am saying. So so let's say you are writing something called WORD. Okay, so you are typing it. So first word is W, and suppose it sends, the keyboard sends only one word at a time. So the controller says that W has arrived. It sends this W to CPU. The CPU has to send something called, say, acknowledgement back. It has to send something like acknowledgement back. Okay, so now by the time the word W reaches here and something called acknowledgement comes back, the other things had appeared. ORD. So what will happen at that time? So basically this channel is full, so it will, controller will say, okay, now the acknowledgement has not received yet, so let me put these things in here. So O, R and D will be stored in buffer. Now when the acknowledgement comes, controller checks, oh, now the acknowledgement has come, so let's release this O to here. Okay, so the task of the controller is to send data, to receive acknowledgement, and to maintain buffer, right? So these are the jobs that controller are doing in that case. Now what does the OS does? OS needs to communicate with this thing, right? So OS, for OS to communicate with the keyboard, it needs something called driver. So the driver will tell the OS what kind of keyboard we are using in plain and simple terms. So different companies have different specification, different channel of working. So that helps, the driver helps them, the OS, to understand what kind of keyboard it is using, and also the messages or kind of acknowledgements that this keyboard uses. So that is why driver is used. So that is the main difference between a driver and a keyboard. So while a driver and controller, so while the controller is basically your brain of the peripheral device, the driver, on the other hand, acts as your means of communication for the OS with that peripheral device. So that is the difference between your controller and your driver. Okay, now. Okay, fine. So let's get back. So let's get back to where we are. So this is how computer or the OS interacts with your periphery. Here it is, your disk controller, USB controller, and those kind of things. So what is now? Now let's discuss what happens during startup. So what happens during a startup when you're booting the device? So OS is something which needs to be present while we start the device. In other words, let's say OS is the first application software that is run during startup. So this process is called booting. So what happens during booting? So the OS to be present even after the we are shutting down the computer or starting the computer, it has to be stored in your ROM, read-only memory. So when you start your laptop or desktop, so this is the first program that OS start. So your desktop start. So this is also known as uh, init program, or better known as initialization program. So that is what the bootstrap program indicates or means. So as you see the first system process. So we will come to what is process in the future lectures. Don't worry, but let's define process as a program in running. So you have written a C program. So when you run that program, that is your process. So init is the first process when you are putting up your program. Now,
Sir, what is there regarding Bootstrap program?
uh-huh.
Sir, Bootstrap program is loaded into memory just because RAM is volatile and it is stored in ROM backing
Yeah, yeah,
secondary memory.
yeah, yeah, yeah. That is
So
correct.
when RAM is volatile, that is RAM is switched off while the computer is switched off, RAM is flushed out.
Mm-hmm.
So we need to bootstrap from ROM to RAM. But in this text which you have presented, it is said that bootstrap is also loaded into memory while we reboot. So whilst rebooting, the power is still on. That is, volatility has not been achieved by RAM. That is, RAM contents are also there just because power is on. So how
See,
is
see,
that?
see, 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 see. Restart is a special form of your power on and off, right? So what happens during restart? You are again. So basically, what happens in since you are into this? So let's say like this. So here you have your ROM. Here you have your RAM. So initially, the OS is here, and suppose it is in state 1. So when you power on it, it gets transferred from to your RAM, right? So now you are changing some things, some programs here and there, so you are writing some things. Now what happens? uh, OS changes from state 1 to state 2. Now when you're powering it off, you are again sending it back here. So this entire process also happen when you are when you are restarting it. The same process only happens, nothing different.
Leading to OS configurations being changed.
Yeah, it is not always being changed, but this is the way that is happening. Okay, so let me give you an idea of this. So if you have been using the latest Windows software, let's say Windows 11, so these things have a thing called that Windows update happens always on the fly, on the go, right? Now when you are like, suppose you have changed something in the code section of the OS. So what I generally do to many of my friends who are not tech savvy, so what I do there, go and do there, I stop this update service. I stop the update service. And how do I do it? I just say to the process, I go to the process manager and I do what? I say that never enable this process while boot up. So when you are doing that, you are changing a configuration of your OS. So next time when your OS is booting up, it will be in that state only, that no update, always no update. So yeah.
In what words? Clearing CMOS or clearing BIOS read?
I didn't was not able to hear you. Can you speak?
Yes, sir.
Can you please write?
Yes, sir.
So that is a kind of thing that happens always for your uh, why your OS has to change. Sometimes configures the state differently. Uh, is this what is clear COS and CMOS BIOS? Yeah, BIOS is kind of your boot configuration system. It is, yeah, it is part of your that init process only. BIOS, that BIOS part goes in there. Clear CMOS is kind of different. You are going into your electronics part. So what happens in your CMOS circuits? There the clear happens. I don't know much about CMOS, but that is what my idea is. But yeah, BIOS is your primary part of your OS during boot up. Yeah. So let's get back uh, to this. Now, there is another term called interrupt that is being introduced. So, what is an interrupt? So, what is an interrupt? Interrupt is basically, yeah. So, interrupt. So, interrupt is basically, let's say you are running a program. Okay, you are running a program, your C program, coding your uh, so all of you have written C code, I am assuming, right? You have written a C code and run the code, right? That is, I assume you have done. So when you are running a C program, suppose you want to stop the running, what you will do? It is a very long program. Suppose it is running, it has to run for 30 minutes, and you want to stop the program. What you will do?
Kill the process.
I mean, that is a very high definition you are going. Kill the process is correct, but I don't want to go to that. How do you kill the process? How do you do that?
Sir, well, deadlock अगर it is a deadlock resolution technique also.
Yeah, so let me say you are running the code on Linux terminal. Best way to do is Control plus C. Control plus C will kill your process. Okay, but let's say terminate your program.
The
That
control just preempt, मतलब not preempt, just it goes into background. The process just goes into
Yeah,
background.
control M is different. When we will come to those things back, but Control plus C just terminates your program.
Sir,
Yes. Yeah. Hi. Yeah, Rudra, what you are saying, you can say.
this is suspending the process.
Yeah, can you please type? I'm not able to hear you, what you are saying.
Sir, I'm just saying that I have seen a control seeing a process
No, no,
and
not
then
you. I'm talking to Rudra. I have heard your thing. So, what is suspending the process? Suspending a process is also yeah. I don't want to delve into process today because it will come into in your other classes. But let me say it like this. So your code is running, and in the meantime, your system has gone out of memory and it is not able to run it. That time, that is one part of suspending the process. Other part, let me say like this: you are running a code and your code requires certain your code requires certain amount of let's say like input, but that input port is not open at that point of time, so that time process is suspended. That is called suspending of process. Yeah, but we are talking about interrupt. Let's first discuss interrupt. So what is an interrupt? So basically, suppose you want to terminate a uh, yeah. So basically, you want to terminate a program. So what you do is press Control plus C. So that is a sort of what Kalpesh told is correct. That kills the program, but that is an interrupt. Control plus C is an interrupt. So that is what called interrupt. What does an interrupt do? It creates a event. It creates an event that the user is saying to stop your program. That is an interrupt. There are other forms of interrupt we'll discuss now. Let's just go through it more.
One thing I want to tell you, that is while while observing control plus C in Linux, I have just like uh, running process. You are saying it killing it. It just that it remains in RAM. It does not kill it from RAM completely. That is after going through multiple processes and then control seeing them every time you see it. Then it just remains in process when there is a list that is called of running processes.
Yeah, that is your running process is something called those that you can find using that ps command that through you can run. And to kill that also, that you need to need that process id to kill it.
Yes,
But
sir. Once I overflowed all processes, the control C and then RAM was full. I was not
yeah,
able
yeah,
to.
that time, yeah, that is the problem, because at that time your interrupt is not working anymore, right? That is all, that interrupt channel is also stopped. That happens. That is nothing uncommon. That time you might have to kill your use process using PID. That is, if I know correctly, that has may have higher precedence that your control plus C kind of killing. Yeah. So now let's say that what I said, this control plus C, while you're running a code and to terminate it, there is also something called hardware interrupt. Now, what is hardware interrupt? Let's just focus back into your keyboard example what we are giving, and where the keyboard sends the word K to your CPU. So that is also a hardware interrupt. Why it is a hardware interrupt? Because your CPU is running in the background and it is doing some other work, but the keyboard lets it that CPU know that now I am sending a keyword, a word, you need to accept that, and that is kind of what is called hardware interrupt. uh, yeah, like other than that software interrupt, I said control plus C. Another is this software generated interrupt is trapped or exception. Like divide by zero, when you are writing a code, these kind of exceptions can happen. If you have written something C++ code, C code doesn't throw exception. In C++ code, there is these things called exception. Those are also software generated interrupt. So this is what we call interrupt driven operating system, or hardware is also interrupt driven.
Sir, I want to ask you a question that while trapping in segmented paging, what is that trap kind of trap? मतलब not an error or a raise your request.
Segmented paging. Can you repeat again?
Segmented paging has a trap that is located in it if the process last address is more than the limit of that.
Okay.
For example, if S1, that is segment 1, has 10 addresses, 10 size of address, and if any process is requesting 11, that it should be trapped. Trap.
Yeah, that could be. I mean, that is kind of a trap, maybe.
So is that a error or just a user request? Just because a process does not user request on it is not an error. Why it is trapped? From which criteria it is trapped?
Yeah,
Cause of
but I mean, let's say you are requesting 10 and you are getting 11. That is kind of some kind of error or exception, right? Overflow cannot happen, right? Underflow can happen, but overflow is difficult to handle for your CPU, right? Okay, we'll come to segmented paging later in the syllabus. Don't worry, then you will ask again. Okay, so we have discussed what interrupt is. Now let's get into some details of interrupt. So interrupt. So what happens during interrupt?
sir, are these notes same as uploaded on the website?
Yeah, yeah, I'm using that only. So so this is your, let's say, IO device. Here is your CPU. Let's say it is working on its own, and let's say this device is a, let's say, keyboard. Now it sends an interrupt signal. What does this interrupt signal will let it know? It will let it know that keyboard is ready, get ready for data transfer. So as soon as CPU gets this interrupt, it acknowledges it as well as starts the interrupt control routine or interrupt service routine. So what does interrupt service routine does? So when an interrupt happens, it executes this interrupt service routine. So this interrupt service routine has its sets of features and codes through which you can transfer this data at a given time. This is what your interrupt service routine does. So interrupt service routine is basically a set of modules or codes which is handling of this particular kind of data. Now another thing is called, so this interrupt service routine is stored in main memory. So whenever this interrupt happens, the CPU in, let's say, gets this interrupt service routine from the main memory. So another thing is there called interrupt vector. So what does interrupt vector has? Interrupt vector contain addresses of all the service routine. So let's say there are 4 service routines. So each of them address is stored here. So so basically this IO device may send, let's say, ITR 1. So similarly there is another IO device, let's say not keyboard, let's say printer. It sends another interrupt signal, let's say ITR 2. So this ITR 2 may have another interrupt service routine. So that's address, that's interrupt service routine may be present here, and it's stored in this interrupt vector. So just think about this vector is basically an array which is stored, which stores the address of this interrupt service routines. So that is how your interrupt service routine works, and interrupt
Does it
vectors.
have an array? Array of pointers, right?
I mean addresses. Yeah, pointers is not a good term to use, but let's say address at this point of time. So main memory addresses are hexadecimal numbers which are stored there. Okay, so this is how interrupt and interrupt the service routine works. Other than that, let's say this is a interrupt timeline. As you can see, that is these timing signals. If you have gone through your digital logic design class, you will understand these timing signals. So as you can see, this is the ideal transfer time of a IO device. So let's say this, and then when it goes up, that means it means transfer is done. So at that time it sends a small, let's say, signal to the CPU that this transfer is done. So that is how your interrupt occurs. Next, let's say this is your flowchart for your interrupt survey driven IO cycle. So the device driver initiates the IO, then IO initiates get ready, input ready. Then the CPU checks for interrupts for execution. CPU receives the interrupt handler returns from the interrupt. CPU resumes the interrupt, and these are the part how CPU works. And this is how the IO controller works. So this is how the, let's say, see the device driver is in action in its CPU side, and the controller is in action in your device side. So this is how your interrupt interrupt cycle takes place in your uh, in the CPU and the IO. So this is a complete different cycle, and this is a complete different cycle, and here this number 4 is basically the interrupt, you can say. So these are the various vectors that are present in your Intel processor, but there are many others also. You can see some common are divide by 0, null interrupt, stack fault, page fault, bound range exception. That is something which happens commonly when you're using an array, floating point error. Then let's come to the storage. Let's discuss storage directly through this. So at the top of the food chain is your registers. These are present directly inside your CPU. Your CPU has your registers. These are the costliest memory that is available. Okay, and it is very fast. Let's say like it data transfer happens within like in terms of let's say 1 unit time. Let's say in 1 unit time this data transfer happens through this. Okay, the catch is it is very small because it is very costly. So the size that is being transferred or the size that it can store is very less. The next in the food chain is, let's say, cache. Like cache is something you are very much heard about, that your computer has six MB of cache, say 1 GB of cache, those kind of things. So what is cache? Cache is also a form of your memory, but it is faster than your hard disk. While your hard your in your then your main memory is your RAM. While your main memory is basically DRAM, cache is basically SRAM. SRAM is faster than so it is used for cache. Yeah. So what happens in whenever uh, suppose your CPU requires a chunk of memory, it first checks whether that memory is present in your register or not. If it is not present in your register, it checks the cache. If it is present in your cache, then it directly gets it from your cache, else it fetches the main memory. So this is how cache, main memory and registers work. Now beyond the main memory, then comes your non-volatile memory, that is your hard disk. So when something is not present in your main memory, at that point of time your non-volatile memory or the disk hard disk come into play. So something you need from your disk, that time you call your disk controller that okay, I need this amount of memory, it fetches it, it stores it in the main memory. Now the entire chunk is not needed, mostly let's say 50% of that address is needed, then it stores that into your cache. So the next time anything from its locality, it's able to fetch from your cache. So that is how your cache, register, main memory takes place. Now, if you look at the graph, you say that the storage capacity is smaller in the top and it is larger at the bottom. It's simply because of the cost. The cost of putting more register and cache is much high than putting, let's say, more your non-volatile RAMs and those things. Similarly, the thing goes with access time. Registers have like much faster. Let's say it can do the time in 1 unit time. Cache takes, let's say, 2 unit time. Main memory takes 4 unit time. So that signifies how fast it is. Okay. Now this talks about that thing also. Now let's talk about the units of storage. The basic unit is bit, that is 1 bit, 2 bit, 1 bit. So it has one bit has two values, 0 or 1, and a byte. Then there is byte, the bigger chunk. It basically 8 bits of storage is called byte, and the other part is word. Word is basically one or more bytes. Now that is a bit controversial, how much bit or byte is a word. So generally let's say 32 bit some. So this is very confusing, but as you go across this course you will find this term, you will be much more accustomed with this term word. So in some problems it may directly specify that 32 bit is a word, some may say just a word, and you need to do the sum according to the word calculations only. So this thing will come into handy while you are doing your exercises further down the timeline. In the meantime, just assume word is basically a number of bytes, one or more bytes. caching, register, memory done. Then IO structure we have already told about local buffer, device driver kind of things, and how keyboard operates as a kind of IO. Then we need to come to this thing called direct memory access. So what happens in a direct memory access? So in a direct memory access, so this is your main memory. This is your CPU, and this is your IO. So what happens in the DMA mode of data transfer? There is something called DMA controller. So what when we are using the DMA mode of data transfer, so what happens? The CPU says the DMA controller, look, fetch 10,000 MB of data from, let's say this is a pen drive, from PD1, let's suppose, from PD1. So what it will do in this kind of thing is, the DMA controller will replenish the job of the CPU, and it will transfer this data to MM. So what happened previously was this in CPU or some chaining based system, it has to go via this to this. So the problem is the CPU was doing this work of data transfer. Now the actual reason why CPU replenishes this job to a DMA controller is because data transfer is basically, IO devices are much slower than a CPU. So CPU has to wait a long if it has to do this data transfer work. So as a result, it uses this DMA controller to do this job of data transfer. Oh, sorry. Sorry. Yeah. So as I'm saying, this. So I have an IO device, let's say, and I have this main memory, and then we have this CPU. Now we are discussing DMA mode of data transfer. Okay, so the main feature of this DMA mode of data transfer is something called DMA controller. So let's say this is a pen drive PD1. So your job is the current job is to transfer data from this PD1 to your main memory. So in CPU mode, what happens, or in generally, so this sends us interrupt that okay, I am here to data transfer. This sends acknowledgement, okay, send the data, then it sends this, then it sends that. So this chain of transfer of data happens. Now the problem is IO devices are slow. Why? These are non-volatile memory, right? So these are very slow. So these are very slow. As we have seen at that structure, these non-volatile memories are very slow compared to your cache or something like that. So the problem is in this kind of data transfer that CPU remains idle for a long period of time. So let's say a very useful mode of doing data transfer is a DMA mode. So what happens, there is this thing called DMA controller. The CPU on receiving an instruction like this or interrupt like this that the IO device is ready to transfer data, what it does, it requires this job to DMA controller. So now the DMA controller transfers this data from this PD1 to main memory. In the meantime, CPU can perform other tasks. It does not have to get occupied with this data transfer job. The DMA controller is doing it. Basically, it's a slow job. That's why DMA controller is doing it. So once the data transfer is done, the DMA controller informs the CPU that the data transfer is completed. Now you can access the data in your main memory. That's how the DMA controller and the DMA form of data transfer works. Any question regarding this? I mean, this is very fun. This kind of data transfer mode is quite different from your normal data transfer mode. Yeah, so any doubt? And then I will move to the next one.
No, sir.
Yeah, okay. So now we come to different kinds of computer architectures. So you have your general purpose computers, single general purpose computer that your CPU, that your device is like a mobile device or your laptop. Then you have your multi-purpose processor systems. Multi systems. So generally, your laptops, your desktops or laptops, you will hear this term quite often. Dual core processor, quad core processor. Your even your mobile, which is generally uses this Qualcomm processors, or so you will hear this octa core processor, quad core processor. So what are these? These are basically your CPU having more than one core. This form of computing is called distributed computing. So let's say this is how it looks like. You have more than one CPU core, each have their own registers and cache, and they are connected to an L2 cache, and that is connected to the main memory. So suppose you are working on a let's say two of this. Suppose you are playing a game on your mobile, and you are also listening to song. So let's say the song can work on can be executed on one of the smaller cores. Like all the cores are not equal. Some have more power, some have less power. So these Android mobile phones previously, these octa-core things used to hear this thing that four cores are clocked at 2 gigahertz, and four cores are clocked at 1.5 gigahertz. These are common specifications you will hear in your mobile devices. So there how comes the core part. So suppose you are listening to song, that song can be executed one of the smaller cores that is being clocked at low speed. Whereas something when you are playing a game, that may get executed in a faster course. Let's say uh, as let's say that one that are clocked at 2 gigahertz. Now a question will arise. So sir, like I am playing a game, and how can four different cores with having their own registers and L1 cache operate on the same data? Yeah, so that's the beauty of this multi-core system. So it maintains this L2's cache, maintains their some form of mechanism which we'll discuss, which is called cache coherence. So using that, they maintains this data that both all the cores are accustomed to a certain amount of data which are not corrupted, which are present in uniform in the main memory. That thing is called cache coherence, which we'll discuss later on this course. So think of it this way, that there is a mechanism to control the data, that doesn't get corrupted between the cores. Right. So this is what the thing core that you will generally hear in your laptops or desktops or your mobile phones looks like. Then there is this thing called clustered computing. Okay, I don't agree with the term clustered computing. Let's call it distributed computing. What is distributed computing? So you have you are working on your social media. Let's say Facebook. Facebook doesn't have only one server. If it has only one server, what will happen is that, suppose that one server is present in US. So any outrage in US, uh, your person sitting in India will have problem accessing that, uh, accessing the Facebook profile or your Facebook chat, right? So what they do is they maintain multiple such copy of servers across the globe. Suppose one server is in Mumbai, so even if one is in, let's say, Dubai, uh, closely related, one is in, let's say, Japan. So that is a form of distributed computing where multiple same thing, same program is being stored at multiple locations. So as to just one of the objective is to faster processing. The person in India can uh, access directly the Mumbai server, and person in, let's say, US directly use the US server without having to go from, let's say, Dubai server or Mumbai server. So that is a form of your distributed systems. Okay.
Sir, does this provide reliability for tolerance as well?
Uh-huh. What?
Does this provide fault tolerance and reliability as well?
Yeah, obviously. Those are the main focus of your distributed computing kind of thing. Otherwise, otherwise it will be very difficult.
Sir, what is the difference between multi-processing and multi-programming?
Multi-programming is running multiple. The term only defines it. Multi-processing is different. Multi-processing is it deals with your um the cores. The cores, it has multiple cores running different processes or same process. Multi-programming is just running the processes. A single core can run multiple programs, right? That is not a problem. Okay, so let's, yeah, that job scheduling kind of thing. A single processor can do multiple programs. That is not a thing. Interactive time scheduling, virtual memory, these are just terms that will come to you later in the course. User mode and kernel mode. So uh, so let's say kernel mode, the program that operates in kernel mode is basically the program that OS can run, not you cannot run. Or an user mode is the programs that you can run. Let's say a word software, that is a thing that you can run with, you don't need user permission. So suppose you will see some of the time that you are supposed trying to open some software on your stored in, suppose say that C drive, and it will say that you require to write something in your C drive. You will get this prompt. I am sure that sometimes you get this prompt while writing some file in that Windows 32 folder, that you don't have permission to do this. That is because that portion of the part of the system you can write only in kernel mode. Only the OS has the power, or the administrator has the power to run that kind of code. Whereas the user mode, you can write uh, only those part of the code that only you can allow to run. So kernel mode is basically having the power that only OS can run. User mode is that only user can run that code. So in a hindsight, kernel mode is much more restrictive than a user mode. that user mode program can be run by OS as well as by the user, but a kernel mode program can only be run by the kernel itself. Okay, so that's of this part of the uh, revision. Now let's jump to your problem solving.
And one thing I want to ask, in C programming, when we write, when we want to allocate memory, we just write a malloc function.
Mhm.
So malloc just allots a piece of chunk of memory to us so
Yeah,
that we can store any kind of structure which we created. So organization of memory as well as its management is in the hands of OS, and we are writing malloc function and then we are extracting the piece that we
yeah.
want from.
So what malloc is doing, what the internal structure of malloc is doing, that getting the chunk of memory, or that this address is free, to locating that address is free or not. So that part is basically done in your kernel mode, that the OS does. But what you do with that memory after it is allocated to you, it's all in your hand. That is your user program. Those kind of jumps occur, like that is common.
So do we write only user calls or do we write system calls as well in our user
No,
code?
you cannot write system calls. You can do system calls, but you cannot write those system calls.
Sir, can you give an example?
System calls. Let's say, like, uh, mm, like you say that, like like you say that creating a process or running a program, right? You can run a program, but the background objective of what are the resources that it has to be allocated for it, that you cannot determine, right? Suppose your program requires 50 MB, that allocation has to be done by the OS. So for that it has to do the system for the kind of things, right?
So we use dynamic memory allocation for this heap section.
No, no, no. Heap section, you are doing dynamic memory allocation, it is okay. But you are being allocated to it. That memory is being allocated to you, right? It is not that directly you are asking the CPU, give me this. OS does that for you. Or you are not directly asking the main memory that give me this. OS is doing that for you. Okay, so let's solve some questions. I don't think from next week I will be doing such a big revision. I will most probably be, the questionnaires will be much more difficult than that one which we have now. So, which of the following is not uh, true for Bootstrap program? You can answer in the chat if you want. So, which of the following is not true for Bootstrap program? Invoked at the power up or reboot, resets and ROM EEPROM perform system initialization. D, user performs user management. Yeah, it is D. Yeah, D is the correct answer. Your Bootstrap program does all of this. Uh, Power up, reboot, all the time Bootstrap program is used, and it is stored in your ROM, and uh, it performs the system initialization. So system initialization is it starts that init process that allocates all those kind of mm, uh, objectivities of the OS.
Sir, what is user management?
User management is profiling, right? So uh, in when you are uh, creating a OS, when you are creating installing a OS, I hope you have installed a Unix machine, right? it it asks that, do you want to create a user, right? Every time any OS you install, it asks you to create a user. So how do you create a user? You give your name and a password, right? So the next time when you start your PC, it comes to the prompt, enter your username and password. So that is user management. That Bootstrap doesn't do. That is done by that init program or some other program maybe. But that Bootstrap doesn't do. Bootstrap work is just to start that init process and other process. Okay, so system calls are executed in user mode, kernel mode, both user and kernel mode, none of the above options. Yeah, it is B, kernel. Yeah, B it is. So, uh, so what do you mean by system call? Just can anyone say what do you mean by system call? Yeah, can you be please louder? Yeah, what do you mean by kernel mode? Well, system call. Sorry. Yeah, one of the system call is that what we are discussing, that malloc and calloc, initialization of memory, that allocation of memory is one thing called system call. I'm not able to hear anything. Is what you are saying?
It is another memory allocated function that is normally used for required memory.
System call.
So system calls are used whenever we want to switch a process from log state to steady state. ISR is executed.
So system call is basically kind of your, let's say, system calls are API that programs use to use OS. Yeah, that is correct. That is absolutely correct. System calls are API that program use to use OS. Absolutely correct. Like that that malloc and calloc example actually makes sense due to this. That you need to get some memory chunk. So what you need to do? You need to do a system call. Yeah, Pavika is also correct. Rudra is also correct. Okay, so let's go to the next one. So which of the following is true as one proceeds higher up in the storage hierarchy? So the storage hierarchy, as we have discussed, is basically register, cache, main memory, and then your those kind of secondary memories. Yeah, so the answer will be your capacity decreases, speed increases. That I know. No, no, no. C is not correct. It's a so so what happens? This is speed. Let's say also cost, and this is your
Capacity.
capacity. Hey, you. This is a very standard diagram which you will encounter later also. I mean, if you have done that course on computer organization, then you have already been accustomed to these things called cache, main memory, secondary memory. The objectivity, if you when you enter the realm of cache and virtual memory, both subjects are same. That computer organization and operating system are same. So if you are preparing for those gate exams, you will see a certain peculiar kind of questions that arises where you have to use the knowledge of virtual memory, and that is specifically paging, that is part of OS, and also it will involve the use of cache. So they may have L1 cache, L2 cache, cache and paging. So that is a very tough problem, but at the same time, the procedure is very easy to do once you have understood it.
Yes.
Single user computers can be used one user at a time, designed for use pretty much for good performances. All of the other options. Single user computer is your normal PCs that you use, only one user at a time. But let's say it is not also one user. In your single user PCs also, you can use create multiple user and do. So if you are
Third option, just because optimized for good performance can also be optimized in distributed system as well.
yeah, I mean that is let's say the distributed system has in its own fault also. Okay, so it is not that you will always get a very good performance in a distributed system. So in a distributed system, one of the main thing is that you need to maintain those things called coherence among the data for some instant. And one major thing what you need to understand about this distributed systems problem is that the rate of data transfer. You will be transmitting that data over your let's say optical fiber or those kind of things. So the data transfer is much slower compared to what happens inside a single PC. That inside a single PC, whatever stays inside happens inside, nothing more. One primary example. So you are writing a Word, and also there is Microsoft Word. Also there is Microsoft Word Online. It may seem that that the one that is using you are using in your laptop are much better compared to one that you are using over the internet, because obviously internet has its own policy. You can be disconnected at the same time while you are writing it, but when you are doing it on your PC, nothing such problems arises. So you can say a good performance there. ease of use. Resource utilization optimization is a goal for single user system, multi user system, both single and multiple user system. D, none of the above options.
Option B.
Yeah, but why not C? I mean, everyone wants to do resource utilization, right? Single user also wants to do resource utilization because in one laptop you are running more than one programs at a time. Suppose you are like for suppose now I am recording this using OBS and also I am teaching it using my that Google Chrome. I also do. So my OS is also trying to do resource utilization only by allocating how much memory you can do in both the programs. In multi-user, the resource utilization happens in different because in a multi-user system, the memory is being shared. So both of them needs to the OS needs to utilize that how much memory you can go give to one. So C will be the correct answer. Like resource utilization optimization is a goal for both of them. Right. So let's go to the next one. So from the point of view of a computer, its operating system is a resource allocator control program. Both resource allocator and control program, neither resource allocator or control program.
Option B.
See, it also allocates resource. C is the answer because resource allocation is means that maintaining the memory and the number of processes that it can do. So it does both resource allocation and control program. What do you mean by control program?
That is protecting those passwords, etc., which we type.
Yeah, is that the only control program? I mean, think about it that it also needs to take inputs from peripheries like your keyboard, your mouse. You need to that is a kind of control, right? Like I was discussing that pen drive example, that transfer of data from pen drive to main memory. That is a kind of a control execution, right? It needs to check how much data is being transferred, whether it has that amount of data present or not. That is also a point of checking where to put the data, like in which address of the memory you need to put the data. That is also kind of a thing it can to do. Also, control program means that user mode and kernel mode, whether a program that is written in user mode can it can so let's a program written in kernel mode, can it run in user mode? Somebody is running trying to run it, then you will throw an error. That is also kind of a control program.
That will be trap and
Yeah, but it is a kind of control program, right? That it is a control signal that it needs to check.
sir. But one question that I would like to ask in this, just because in control program, while we like enter the password on the Facebook site, email address, password, where is that stored?
So it is stored in your remote secure database. It is stored. Okay. Thing of the grasp of the matter is it is being encrypted, and Facebook also doesn't know your password. It is directly being encrypted to.
I have implemented algorithms in which the thing is it is stored in RAM, and if we get access of RAM, then we can view those
Yeah, I mean
passwords.
that is, let's say, a very naive way of programming, right? You are writing a code or to store it in RAM. That is never going to be you are storing it in a non-volatile in a volatile memory. That is not how your Facebook kind of Facebook or your OS kind of data product like password protection works. In those kind of systems, they store it in a secure place, and by means of security, even they doesn't know what is your password. It has to be encrypted and stored.
So encryption is done that way, which we study in network, or there is other ways of OS as well.
Uh, that is a mystery. What kind of encryption everyone uses, right?
For example, SMTP encryption, network
Yeah,
layer.
there are different, like AES is there. Like the truth of the matter is your laptops and desktops come with your encryption chips that is already present. There are different kind of program CPU cores that are already present in your mobile and laptops for this kind of encryption procedures.
Thank you.
Hmm. So it is both resource allocator and control program. So the first process in Unix is obviously int. We have discussed this, that int is the first process that has to be that the Unix starts. Next is system calls are invoked via soft hardware interrupt, software interrupt, call to procedure. Hardware interrupt. Software. System calls are software. System calls are software.
Sir, but device drivers, etc., which are installed,
Those are
for example,
those are not device driver, and those kind of hardware. Those are not device driver is software interrupt, but hardware interrupts are different. Hardware interrupts are those coming from controllers. Okay, that comes from the periphery. System calls is the mechanism, as you said, the API to communicate with the OS. That is a completely program that is in software domain. What is call to procedures? And that is your normal function calls.
call by value, call by reference.
I mean, let's say that normal function calls. No, let's not complicate things. Call by value.
Sir, can you example of hardware interrupts?
Yeah, I mean, hardware interrupts are discussed, right? Whatever we are doing during that keyboard example, keyboard interrupt, those kind of things. Your printer is saying, okay, I am ready now. I can print. Those kind of things are hardware interrupts. So interrupt vector contains list of interrupts available in the system, list of interrupts occurred at a point, address of interrupt service routine, return address of occurrence of interrupt service routines. So interrupt vector contains the address of the interrupt service routine. List of interrupts, sir, will hitting reboot while running a process be example of interrupt? Nice question.
Yes, sir, of course, killing the process or matlab,
Depends on how are you trying to reboot it. Are you trying to just press that power of keyboard to reboot?
sir, for example, turning off power or
Yeah,
power
yeah,
shutdown.
yeah. It is an interrupt. It is an interrupt, and in that case, it is a both hardware and software interrupt. Like suppose, let's say you have your mobile phone. It has a restart button. It has a button. So you click on it and you press restart. So at that time, it needs to kill the software that are running. So at that time, it has to kill those. So that is a part of your interrupt. Okay. So size of word in a computer system is 8 bit, 16 bit, 32 bit. I will say that it will come 32 will come your most of the times it will come 32 or something, but it is basically dependent on the system. So direct memory access data transfer occurs between CPU main memory, CPU secondary memory, main memory and secondary memory. Option D, none of this. Okay, where are we? What were we? From where to where we were transferring data during direct memory access? In that example,
Can you repeat?
where were we transferring the data in our example during DMA?
So because main memory speed is slow and memory speed is slow as compared to CPU. So
Yeah, but from where to where we are transferring?
the secondary memory to CPU.
To CPU. Where were we storing the data?
What's that?
Where were we storing the data?
Then I didn't get it. Can you repeat?
Yeah, so what were you doing here? What were we doing here? From where to where we are storing the data? So we are transferring basically the data from PD1, that is a pen drive, to your main memory, right? So this is basically a secondary memory and this is your main memory. So the correct answer will be between main memory and secondary memory. Think about it. What happens normal data transfer between a main memory and secondary memory? It uses CPU. But in DMA controller, DMA just passes the CPU. CPU says, "Do DMA controller do it." I will at this point do some other work. DMA controller completes the memory transfer from your secondary memory to main memory or vice versa. Once it is done, it informs the CPU, okay, my transfer is done. Now you can check your memory in the main memory.
Like a handler.
Yeah, it is kind of an handler, but it doesn't require permissions on those kind of things from CPU for transferring this data. Once CPU says to the DMA controller that now you can do this, it relinquishes all the permission to the DMA controller. DMA controller transfer the data from secondary memory to main memory or vice versa, and then it relinquishes the transfer the your permissions back to the CPU. So what about the PCI, like video card, PCI like video card memory? It is also handled by DMA controller. Yeah, it maybe there are some higher level controllers that are available. Maybe that these are basic things that may be also present, but uh, normally CPU doesn't bothers about to these days to control these kind of things.
Sir, the example that you are referring to, that is pen drive contains a video and just we click on, double click on the video, it does not require even coming to the main memory. The direct memory access just comes into work that time.
Yeah, at that time, video playing is a very different thing. What happens in a video play? Video player is running. The video player is basically a software that is running on your CPU. That CPU is running. So CPU has to get the data. So if it is stored in directly in pen drive, it has to bring it to the main memory. Yeah, kind of. Okay, I got your point. Yeah, that is the kind of the thing may have been referring to. Okay. So between L1 and L2 cache, which one is private to CPU? So always remember L1 cache is private to CPU. So
C.
no. Eh, so in a multi-core system, CPU 1 and there is CPU 2. they have their own register set, they have their own register set, they have their own L1 cache, they have their own L1 cache, and there is this L2 cache that is being shared by these different cores, core 2, core 1. So L1 cache is always private to the CPUs. L2 is shared by maybe more than one CPUs. Don't think about much about it. Like these things will come back in the later part of the course, where you will you will come to more accustomed to these things called cache and all. At this point of time, just remember that L1 cache is common to all, is private to your CPU cores. L2 cache is shared by all the cores.
Okay, sir.
So device driver for devices are generally developed by OS designer, device manufacturer, system programmers, application programmers. Yeah, B. The device drivers and the device controllers both have to be designed by your device manufacturers. They only know how it has to be operated, so their device, their software they have to produce. Okay. Next, we have the storage acts as cache for the secondary storage. We have the following acts as a cache for the secondary storage. The term cache is just disturbing here. It is basically, yeah, it is C. So basically, if you look at the pyramid, again, there is the registers, cache, main memory, and secondary memory. So what happens, this part of the code, let's say this code gets transferred here, so this is kind of a cache for your main memory. I mean, using the term cache is a bad example, but let's say that portion of the, like you are Kalpesh was telling about that video playing thing from a pen drive. So what happens? You have video in your pen drive, and you are started playing it from inside the pen drive only in your system. So that time your secondary memory comes to your main memory. So at a point of time, the secondary memory, suppose let's say, transfers 50 MB of the video directly from into the main memory and then plays it. So as long as that 50 MB, let's say per second it plays 10 MB. So for 5 seconds, main memory contains that amount of video that can be played. So in that sense, it forms like a cache. Okay. So here is the last one. Handheld computer systems are optimized for computation, battery life, and resource utilization. Yeah, so handheld systems are basically your mobiles. Yeah, uh, the bottleneck for your mobile phones are your battery life. If they increase the battery, more softwares can be pushed into it. That's it. More computation can be done. Okay. So that's the end of today's discussion session. Okay. So we will meet again next Monday. Same.
Sir, can you just share the link of recorded session?
Yeah. So okay, I am sharing the. I will share the YouTube link. So you can find it here. Hopefully. Yeah. So I will upload it here. I will upload it here only, but at the same time, I am sure they will share the link in 1 or 2 weeks. And after that, you will just be able to get the video like within the day only. but in the meantime you can just get the video in this link only. Okay, so thank you. We will meet again in the next Monday, same time, 6 to 8.
Thank you, sir.
Yeah, thank you for joining.